if we happen to have two lines which are non-parallel, say something like this and something like this. So we can find the angle between them. When we tell angle between them, this is the angle. So this is an angle. So basically, see, this could have also been the angle. This could have also been the angle. Why do they call this as the angle between the lines? So that's the basic definition. So it's basically considered to be the opposite side of the x-axis. That's how you guys can figure it out. So we are trying to figure out this theta value with the help of the slopes of the line. Okay, so we have been given the slope and we have to figure out theta basically. So the aim of this topic is finding Nemo. If I call theta as Nemo, we can call that as Nemo. Let's do that. Finding Nemo represented with theta with the help of M1 and M2, where M1 and M2 are your slopes of the lines. Okay, so that's the basic funda. So we will start off the working with assuming let theta and alpha be the, we'll call this as theta and this as alpha. So let's call the inclination of the line. Let theta comma alpha be the inclination of the line L1 comma L2. Now what is the next thing? Next thing is establishing a relationship between theta. Oh, I'm calling this as theta, right? Let me call this as beta. So establishing a relationship between beta, theta and alpha. How can we do that? This is beta. That's your clue. Now think about it. Yes, if I consider a triangle over here, clearly what do we have? We have theta will be equal to alpha plus beta, right? So let me do that. So theta is equal to alpha plus beta, okay, because of exterior angle is equal to sum of interior opposite angles of a triangle. Okay, so this is seen in a triangle. Now we are trying to express beta in terms of M1 and M2. So what I have to do is I need to re-express so that we have beta to be alone. So theta minus alpha, right? I'm just rearranging basically. Okay. Next is what you're going to take tan on both sides. So we have tan of beta is equal to tan of theta minus alpha. So we know that tan of A minus B is what? Tan A, yes, minus tan B divided by 1 plus tan A into tan B. So remember that here in the numerator it's minus and in the denominator is plus. This is derived from sin A plus B and cos A plus B, or sin A minus B in this case and cos A minus B, and how sin and cos behaves. So with that you can remember this. Again, if you've seen the derivation what I have done, you will understand where is that I'm talking about. Or if you know the derivation properly, the right manner, then you will understand this. But tan theta and tan alpha are your slopes of the line. So basically tan beta is equal to M. So this is M1 minus M2 divided by 1 plus M1 M2. Okay, so this is your initial derivation regarding angles between two lines using the slopes of the line. And finally, I'll write the final expression. This is how they generally express it as. The modulus of this entire expression is your beta. So this is for 1 plus m1 m2 not being equal to 0 basically. Okay, this holds good for that. Why the modulus? You'll understand in time. So pause, do copy this. We're going to use this as well.